Welcome to the Explainer. So today we're going to talk about this faint, ancient glow. It's literally everywhere in space. And get this, it's not starlight. It's actually the story of our entire universe, right from the very, very beginning. I mean, just think about that for a second. This isn't just old light. It's like a cosmic fossil, a whisper that has been traveling across the cosmos for nearly 13.8 billion years. It's a relic from the dawn of time, and it's carrying the secrets of creation itself. So, to figure that out, we have to go back in time, and I mean way back. We're talking about a time before the very first stars even ignited, when the universe was, well, it was a place we would hardly even recognize. All right, so to really get this, we have to picture the universe in its infancy. Trust me, it was a totally different place. Okay, so for the first, 380,000 years, the universe was just this unbelievably hot, dense soup of particles. I mean, you couldn't see anything. Light, which is just photons, right, was totally trapped. It was just bouncing around off all these free electrons like a pinball. The best way to think about it is like trying to use your car's headlights in a super thick fog. You can't see a thing. The whole universe was just opaque. But, as the universe kept expanding, it started to cool down. And right around that 380,000-year mark, it hit this kind of a magic temperature. It got just cool enough for electrons and protons to finally team up and form the first stable atoms. And that moment, they call it recombination, poof, the cosmic fog just lifted. For the very first time ever, light was free to travel. And that light, the light that was finally set free, that's what we now call the cosmic microwave background. So how did we even find this ancient light? Well, the story is fantastic because it wasn't some big planned discovery. Nope. It all started with this really annoying, persistent hiss coming from a radio antenna in New Jersey. And this is just a classic story of scientific luck, serendipity. Physicists had actually predicted that this radiation should be out there somewhere, but it was two astronomers, Arno Penzias and Robert Wilson, who just stumbled upon it completely by accident back in 1965. And yeah, it ended up winning them the Nobel Prize. So these guys were just being driven crazy by this faint microwave signal. It was constant. It came from every direction in the sky, day and night. And they tried everything to make it go away. They checked all their equipment. They pointed their antenna at New York City to see if it was interference. They even, and this part is famous, they even evicted some pigeons that had made a nest in the antenna and cleaned up, their droppings. They thought maybe that was causing the noise. But nope, the hiss was still there. And then they finally got in touch with another group of scientists, physicists, who were actually searching for this exact signal. And that's when it hit them. That realization must have been absolutely electric. This wasn't noise. It was the afterglow of the Big Bang itself, just stretched out and cooled down over billions of years until it became microwaves. They had found the universe's baby picture. Okay, so finding this glow was huge, but that was really just step one. The real secrets, the ones that explain, well, everything, they were hidden in tiny, tiny imperfections in that light. And you really have to think about this, because it's a huge deal. If that baby picture of the universe was perfectly smooth, we'd have a major problem on our hands. A perfectly uniform universe would just expand into a perfectly uniform and totally boring emptiness. No galaxies, no stars, no planets, no us. So what's the answer? It lies in these things called anisotropies. Fancy word, but all it means is tiny, tiny variations in the temperature of that ancient light. We're talking differences of like 1 part in 100,000. So you have these spots that are just a little bit hotter and some that are a little bit colder. And those tiny temperature differences map directly to spots in the early universe that were a little more dense or a little less dense. And those slightly denser spots, those were the seeds, the gravitational seeds that everything, every galaxy, every star grew from. And over the years, we've gotten a much, much better look at these seeds. We sent up a whole series of space telescopes to map them out. It started with the COB satellite, which gave us the first fuzzy hints. Then came WMAP with a much more detailed map. And then the Planck satellite gave us this absolutely stunning high-resolution view. We literally went from hearing an annoying hiss to seeing a detailed blueprint of the baby universe. So let's talk about how this incredibly detailed map basically became the foundation for everything we know about cosmology. Right, because this isn't just some pretty picture you hang on the wall. It's an absolute treasure trove of data. By analyzing the patterns, the size of the hot and cold spots, how they're spread out, scientists can measure the vital statistics of our universe with incredible precision. And what it tells us about what the universe is made of is, well, it's mind-blowing. It turns out that everything we can actually see and touch, you, me, the stars, all the galaxies, all of that is just 5% of the universe. Just 5%. The other 95%, that's made up of mysterious dark matter and even more mysterious dark energy. It also lets us pin down the age of the universe with amazing accuracy. We now know it's 13.8 billion years old. And it gets even weirder. It tells us about the actual shape of the universe. The data from the CMB shows us that on the grandest scale, the universe is flat. Now, what does that mean? Well, basically, it means that if you and a friend flew off in perfectly parallel lines forever, you'd never get closer together or farther apart. And that little fact has massive implications for how the universe will end. So when you put it all together, it's just amazing. This one single source of ancient light confirms all the major pillars of our modern understanding of the cosmos: the age, what it's made of, its shape, and where all the galaxies came from. It's all there in one picture. It's honestly hard to overstate how incredible this is. We went from a weird, annoying hiss in an antenna to reading the autobiography of the entire universe. This one faint glow tells us where we came from, what we're made of, and how everything is. But you know what? It also points to these huge mysteries that we still haven't solved. The CMB tells us the story of that 5% of the universe we understand, but it's also the best evidence we have that the other 95% is a complete unknown. It's just a beautiful testament to human curiosity, isn't it? It reminds us that sometimes the biggest, most profound answers, they start out as the quietest whispers.